Type of growth form. There are two type of population growth forms: J-shaped exponential or unrestricted growth form, and A-shaped sigmoid shaped logistic restricted growth form. J-shape অথবা এক্সপোনেনশিয়াল অথবা জে শেপ, এটা হলো এক্সপোনেনশিয়াল মানে বাড়তে থাকে, সমানুপাতিক বলা যায়, আনরেস্ট্রিক্টেড গ্রোথ ফর্ম। আর এ শেপ হচ্ছে সিগময়েড শেপড লজিস্টিক অথবা লজিকের উপর ডিপেন্ড করে সিগময়েড শেপ রেস্ট্রিক্টেড গ্রোথ ফর্ম। জে শেপড এক্সপোনেনশিয়াল অথবা আনরেস্ট্রিক্টেড গ্রোথ ফর্ম। J-shape or exponential growth form show the exponential or geometric growth pattern of a population. J-shape কি দেখায়? Exponential অথবা geometric growth pattern of a population. J-shape or exponential growth form of a population occur when there are plenty of resources, where resources are unlimited in a ideal condition. Exponential growth can be seen in population that are very small or in regions that are newly colonized by a species. It occurs in two phases: lag phase, exponential phase. In this growth form, the growth of population, number of individual, density of an organism population in a new environment increase slowly at fast অথবা lag phase due to adjustment in new environment, and low initial number of population when birth rate is slow but increasing. Then the population grow continuously or exponentially or logarithmically exponential phase due to enough or large amount of food material, water, and no predator exist in the habitat. When birth rate is higher than then the population grows continuously or exponentially or logarithmically exponential phase due to enough or large amount of food material, water, or no predator exist in the habitat. When birth rate is higher than death rate, and after attaining the peak value, the population stops or crashes abruptly as environmental resistance, seasonality, or some other factor, the end of breeding phase, or limited food supply in the habitat becomes effective more or less suddenly. Occasionally, the population crash can lead to extinction. The actual rate of population change depend on biotic potential and the population size. Examples: some insect, algae, annual plant, etc. Many insect populations show explosive increase in number during rainy season, followed by the disappearance at the end of the season. This type of population growth is termed density dependent, as the regulation of growth rate is not tied to population density until the final crash. It may be summarized or expressed mathematically as dn divided by dt Rn, with a definite limit on n, where dn dt represent rate of change in population, n population size or the number of individual in the population, t means time, r হচ্ছে biotic potential or constant representing the intrinsic rate of increase of organism concerned. J shape, lag phase, exponential phase. Phases of J-shaped growth form. It has two phases. Lag phase. Growth is slow because population is small. Exponential growth phase. growth is accelerating. 2 নম্বরটা হচ্ছে এ শেপ অর সিগময়েড শেপ লজিস্টিক রেস্ট্রিক্টেড গ্রোথ ফর্ম. A shape or logistic growth pattern describe the habitat with limited resources. A shape or logistic growth pattern describe the habitat with limited resources. This model defines the concept survival of the fittest. In A-shaped growth form, the growth of population number or individual density of an organism population in a new environment increase slowly at first establishment or lag or positive acceleration phase. In S-shaped growth form, the growth of population number of individual density of an organism population in a new environment increase slowly at first establishment or lag or positive acceleration phase, then increase more rapidly logarithmic or exponential phase due to availability of food and requirement in plenty and no competition, but it soon slow down gradually as environmental resistance increases percentage wise. The negative acceleration deceleration transitional phase until a more or less equilibrium level is reached and maintained, or until at zero growth rate the population stabilize. Stationary phase equilibrium phase. In this phase the new organism are almost equal to the number of dying individual, and thus there is no more increase in population size. Mortality natality rate become equal. The point of stabilization or zero growth rate is termed the saturation value, symbolized by K or carrying capacity of the environment for that organism. Carrying capacity is the maximum number of individual of a species that can